The Abu Musa corridor runs northeast from the Strait of Hormuz into the Persian Gulf's central basin, a stretch of water that the Islamic Revolutionary Guard Corps Navy has been using as an operating theater for fast patrol boat operations since the 1980s. The water here is shallow, 30 to 50 meters, warm and opaque with suspended sediment that makes the hull acoustic signature carry in unpredictable directions and reduces underwater visibility to near zero. On a clear night, the lights of the Iranian coast are visible to the north, and the southern horizon carries the glow of the Sharjah refinery complex. USS Milius makes 18 knots on a northeasterly heading, transiting toward the central Gulf on a freedom of navigation route. She's not alone in this water. No ship ever is in the Persian Gulf at 1:14 a.m. The electronic warfare operator has been logging the IRGCN patrol boat network for 4 hours. The emissions picture is normal for this corridor. Multiple C-band search radars from the coastal stations on Abu Musa and the Tunbi Islands. 2 fast patrol boats running their navigation radars on a standard patrol pattern 6 miles to the north. The periodic illumination of a shore-based fire control radar that the IRGCN uses for range calibration exercises. All of it logged, all of it familiar, all of it filed under routine. At 1:09 a.m., the pattern changes. The 2 fast patrol boat navigation radars go dark simultaneously, which is not what patrol boats do when they are patrolling. They go dark when they are maneuvering to an approach position. He reports it immediately. The officer of the deck orders general quarters at 1:09:47 a.m. The watch team shifts posture. The SPY-1D radar, already in active scan mode, begins actively tracking surface contacts to the north. The picture that comes back is not 2 contacts. It is 14, then 22. Then, as the smaller contacts separate from the land clutter and the radar's surface track algorithms begin resolving them individually, 37 distinct surface contacts, moving in a distributed pattern at speeds between 25 and 45 knots, closing from a bearing of approximately 350. This is not a patrol, this is a swarm. The IRGCN fast patrol boat swarm doctrine has been studied in every surface warfare school in the US Navy for 20 years. The concept is saturation, not a single decisive blow, but an overwhelming number of simultaneous vectors, each individually sublethal, collectively capable of degrading a surface combatant beyond operational effectiveness. Each fast patrol boat in the formation carries a mix of RPG-7s and 107mm recoilless rifles, supplemented in some configurations by man-portable anti-armor missiles. None of these systems will penetrate an Arleigh Burke's main belt. All of them will damage topside electronics, weapons mounts, antennas, and exposed sensor arrays if they are allowed to get within range. The doctrine requires the surface combatant to engage at long range and sustain a rate of fire that exceeds the swarm's ability to close. The doctrine assumes the surface combatant systems remain operational throughout. The doctrine does not plan for what happens when they don't. The Milius opens engagement at 1:11:03 a.m. with her 5-inch Mark 45 gun, beginning a sustained rate of fire against the lead elements of the swarm at 7 miles. The CIWS phalanx on the forward mount begins tracking and engaging the closest patrol craft at 1.5 miles. The SPY-1D is tracking all 37 contacts simultaneously, prioritizing by closing rate and bearing. The picture in CIC is managed chaos. The engagement queue is full, the gun systems are firing continuously, and the combat picture is updating faster than the watch team can verbally annotate it. The Milius is fighting the swarm correctly. She is also, in the way that any ship fighting a 37-contact swarm will, taking hits. The first hit arrives at 1:12:31 a.m. An RPG-7 round fired from a patrol craft at approximately 800 meters strikes the Milius's port side at the 01 deck level, frame 78, impacting the base of the aft CIWS phalanx mount. The RPG warhead is a shaped charge designed for armor penetration. Against the CIWS mount's aluminum housing, it performs as designed. The mount's 20mm barrel assembly is driven sideways by the penetrating jet. The tracking radar housing above the barrel receives the overpressure and loses its gimbal alignment. The CIWS mount fires 2 rounds on its last commanded bearing before the fault protection circuit takes it offline. The aft close-in defensive capability of the ship is gone. The gun team in CIC updates the engagement queue. The 5-inch gun shifts to compensate for the lost aft sector coverage. The gun can engage in the aft sector, but with a slower cycle than the CIWS provided. The mathematics of the swarm begin to shift, not catastrophically, but measurably. The swarm's commanding officer, observing from a command boat at 5 miles, sees the CIWS mount stop moving. He notes it. He is gathering information. The second hit arrives at 1:13:07 a.m. A 107mm recoilless rifle round from a patrol craft at approximately 400 meters to port strikes the port side of the superstructure at the 03 deck level between frames 44 and 46. The round does not penetrate the superstructure's structural steel. It impacts the SPY-1D radar array mounting bracket for Phase 3, the port side phased array panel, and the fragmentation pattern from the projectile's base plate spreads across the array face's lower third. Of the 4,480 radiating elements in Phase 3, approximately 340 are physically damaged by fragmentation impact. The SPY-1D's built-in test system detects the element failures and takes Phase 3 to degraded mode. The radar redistributes its surveillance load to the remaining 3 faces. Coverage on the port forward arc drops by 25%. The ship does not stop fighting. The gun continues firing. The forward CIWS continues tracking. The SPY-1D continues the engagement with 3 functioning faces. But the degraded port forward arc is exactly the bearing from which 12 of the patrol craft are approaching. And those 12 contacts are now being tracked by a radar whose sensitivity on that bearing is reduced by a quarter. Some contacts are being tracked with lower confidence. One contact is momentarily dropped and reacquired. The swarm's commanding officer, watching the Milius's engagement geometry change, notes that the ship is tracking his port formation with slightly less precision than before. He pushes 4 boats harder on that bearing. The third hit arrives at 1:14:22 a.m., and this one is different. An RPG round, a PG-7VL tandem warhead variant, fires from approximately 300 meters on the port quarter and strikes the Milius's weather deck at frame 32, port side. The weather deck at frame 32 is not structural armor. It is 12mm steel deck plating, and the PG-7VL's tandem charge penetrates it and detonates in the space below the deck. The space below the weather deck at frame 32 is a utility void that runs the Firemain crossover, a section of 4-inch pipe that connects the port and starboard Firemain circuits, allowing either circuit to feed the entire ship if one main loop is isolated. The warhead detonation opens a 28-centimeter breach in the crossover pipe at the void space center. At 90 pounds per square inch, a 28-centimeter breach in a 4-inch pipe puts approximately 400 gallons per minute onto the weather deck, flowing aft along the deck and cascading over the side. The Firemain crossover is not a flooding hazard to the hull. The breached pipe is above the waterline, and the water drains outboard. But the crossover is the critical link between the ship's 2 Firemain circuits. With the crossover breached, the port and starboard Firemain circuits are now independent and partially depressurized. The port circuit has dropped from 90 pounds per square inch to approximately 55 pounds per square inch as it bleeds through the breach, and the starboard circuit has dropped to 60 pounds per square inch as the system tries to equalize. Neither circuit now provides adequate firefighting pressure at the forward hose stations, where the requirement is 65 pounds per square inch minimum. The ship's firefighting capability has just been reduced to half. In DC Central, the chief engineer reads the Firemain pressure drop on the monitoring display at 1:14:41 a.m. and understands immediately what has happened. He has been in DC Central since General Quarters was called. The board is already showing the CIWS mount casualty and the SPY 1D Phase 3 degradation. Red markers, both annotated. The Firemain pressure drop goes to red as he watches it. 3 red markers on the DC Central board in less than 3 minutes of engagement. Not from a single catastrophic event. From 3 separate hits that individually any ship could absorb. Together, they are building a cascading architecture of degradation that the swarm's commanding officer may or may not understand, but is empirically producing. Outside, the engagement continues. The 5-inch gun has now fired 47 rounds and has reduced the patrol craft count from 37 to 29. The forward CIWS has engaged 9 contacts and disabled or driven off 7 of them. But 22 patrol craft are still in the engagement envelope, and some of them are getting closer because the aft CIWS is not there anymore, and the 5-inch gun's aft sector engagement rate is slower. The swarm is not winning, but it is not losing at the rate it needs to be losing. The chief engineer makes his triage decision in DC Central with the 3 red markers on the board. The CIWS mount cannot be repaired at sea. It is a precision electro-optical system with a disabled barrel assembly, and that repair requires a facility, not a sailor with a wrench. He annotates it as permanent loss and moves on. The SPY 1D Phase 3 degradation requires a phased array element inspection and replacement procedure that also cannot be completed at sea. He annotates it as degraded mode operational and moves on. The Firemain crossover is a pipe. A pipe can be fixed. The fix, however, requires entering a void space through a scuttle on the weather deck. Currently receiving water discharge from the breached crossover and within 50 meters of patrol craft that are still engaging the ship. The weather deck is not a safe working environment at this moment. It is an environment where a sailor conducting a repair could be incapacitated from small arms fire or a secondary RPG engagement. He calls the repair party leader on sound-powered phone. He explains the situation in 14 seconds. The crossover is breached at frame 32 void space. The Firemain is at half pressure, and the repair requires a weather deck scuttle entry. He does not tell the repair party leader whether to go. He tells him what the situation is. He asks for an assessment. The repair party leader's assessment, delivered in 9 seconds, is that he can do it if he can get gun team suppression on the patrol craft, on the port quarter during the repair window. He needs 2 minutes. He needs the gun. The commanding officer, informed by the chief engineer via the intercom, orders the 5-inch gun to shift priority to port quarter suppression for a 2-minute window beginning immediately. The engagement queue shifts. The gun crew completes the current target engagement and begins systematic fire on the port quarter patrol craft, not precision engagement, suppression fire, rounds in the water ahead of and around the approaching boats to force course changes and slow the approach geometry. The volume of fire on the port quarter increases. 3 patrol craft at ranges between 400 and 600 meters alter course away from the ship. The repair party leader drops through the weather deck scuttle at 1:17:33 a.m. with a damage controlman behind him. The void space below is approximately 1.2 meters high. A crawl space, not a standing space. With the breached Firemain crossover visible immediately as a horizontal pipe running port to starboard. A 28-centimeter section gone where the warhead detonation opened it. Water spraying at reduced pressure from both open ends. The void space has approximately 6 inches of standing water from the ongoing discharge. The overhead, the weather deck above, is transmitting the sound of every 5-inch round the gun fires as a physical shockwave through the steel. He is working inside a drum that is being struck from above, in a crawl space, in standing water. with patrol craft audible through the hull plating as high-speed engine noise. The emergency patch kit has 3 options for a 28-centimeter breach in a 4-inch pipe. The standard rubber patch with C-clamp harness is designed for circumferential cracks and small holes, not a 28-centimeter section loss where the pipe material itself is gone. He cannot patch across 28 centimeters of missing pipe with a flat rubber sheet. He needs to bridge the gap. A bridge patch, 2 end cap plugs installed in each open pipe end, connected by a temporary bypass line, is the correct procedure. But the emergency bypass hose in the kit is 3/4 inch diameter. The Firemain crossover is a 4-inch main. A 3/4 inch bypass will reduce the crossover flow to approximately 12% of rated capacity. 12% is not enough to restore firefighting pressure across both circuits. But 12% of rated crossover flow, approximately 45 gallons per minute, is enough to prevent complete equalization failure between the 2 circuits if combined with a second action. Manually isolating the port Firemain circuit at the frame 32 isolation valve and routing all firefighting demand through the starboard circuit, which will recover to full 90 psi pressure without the bleed loss through the breach. The port circuit hose stations will have no water. The starboard circuit stations will have full pressure. The ship will have full firefighting capability on the starboard side and 0 on the port side. It is not symmetrical. It is workable. It is the only option available in a void space with 6 inches of standing water and a 2-minute window. The repair party leader plugs both open pipe ends with the end cap plugs, rubber cone plugs, driven against the pipe interiors with a maul, 3 strikes each. The plugs stop the bleed flow from both ends. He installs the 3/4 inch bypass hose between the 2 plugged ends. Using the hose coupling fittings the plugs are designed to accept. The bypass flow begins, not 90 pounds per square inch, not 45 pounds per square inch, but a controlled limited flow that prevents the 2 circuits from complete isolation. The damage controlman moves to the frame 32 port isolation valve, a 4-inch gate valve on the port bulkhead of the void space, and closes it, isolating the damaged port circuit from supply pressure and routing all Firemain flow to the starboard circuit. The starboard Firemain pressure recovers to 82 pounds per square inch at 1:21:14 a.m. Not full nominal pressure, but above the 65 pounds per square inch minimum for adequate firefighting performance at the forward hose stations. Total time in the void space, 3 minutes and 41 seconds. The repair party leader's hands are bleeding. Not from any ordnance, but from a burr edge on the void space scuttle combing that he crossed 3 times in darkness, fast. He does not report it as an injury. He reports the repair complete and the port isolation valve closed. Above the void space, the engagement has continued through the entire repair sequence. The 5-inch gun has now fired 63 rounds and reduced the patrol craft count to 17. 3 patrol craft are stationary, disabled by direct rounds, and the rest of the swarm has lost its cohesion geometry. Swarm doctrine requires a coordinated approach on multiple bearings simultaneously. A swarm that has lost 1/3 of its elements in 12 minutes and is experiencing sustained suppression fire on its port quarter approach. Axis does not maintain formation discipline. Boats begin breaking off. The closing rate on the port bearing drops. The swarm's commanding officer, in his command boat now at 7 miles and increasing, is looking at a ship that is still firing, still maneuvering, and is being fought from a position he did not anticipate. What he knows is that his approach has not achieved the degradation threshold he needed in the time window he had, and that the longer he presses, the more craft he loses. At 1:22:47 a.m., the swarm begins withdrawing. The remaining patrol craft turned northwest in ragged sequence, accelerating away from the engagement. The 5-inch gun fires 4 more rounds at the withdrawing formation before the officer of the deck orders ceasefire. The gun crew counts the shots, 67 rounds total. The Milius holds course at 18 knots, SPY-1D tracking the withdrawing contacts to confirm egress trajectory. Forward CIWS tracking ahead. Aft sector coverage now consisting entirely of the 5-inch gun on its aft bearing. She is diminished. She is operational. The full accounting over the following 2 hours is specific about both what was lost and what held. Permanent losses. The aft CIWS phalanx mount, disabled at the barrel assembly. The mount's electronics and magazine intact. Only the gun and tracking radar inoperable. Replaceable at a yard facility. Offline for the remainder of this deployment. The SPY-1 to Phase 3 phased array. 340 radiating elements physically damaged by fragmentation. The face operating at degraded sensitivity in the port forward arc. Not blind, reduced. The port Firemain circuit, isolated at frame 32, the crossover breach permanently bypassed by the 3/4-inch hose until yard repair. Port side hose stations offline. Starboard circuit fully operational at 82 pounds per square inch. The RPG impacts on the superstructure exterior left 7 strike marks in the aluminum cladding and steel framing, 3 of which created small punctures sealed with fast-setting epoxy patches by the post-engagement inspection team. 2 topside navigation antennas physically damaged, bent or severed by fragmentation, shifted to backup antennas by the electronics technician watch. 1 exterior ladder on the 02 deck port side severed at its lower mounting bracket, secured with line-pending rewelding at the next yard period. The repair party leader's hands treated by the medical officer at 1:43 a.m. 2 lacerations on the right hand, 1 on the left, none requiring suturing. He was back at his watch station at 1:51 a.m. 37 patrol craft in the initial swarm. 29 patrol craft contacts remaining after initial gun engagement. 17 contacts in the withdrawal. 67 rounds expended from the 5-inch Mark 45. 1 aft CIWS mount disabled. 1 SPY-1D array face degraded to reduced sensitivity mode. 1 Firemain crossover breach repaired in 3 minutes and 41 seconds under active engagement conditions. Port Firemain circuit isolated. Starboard circuit restored to 82 pounds per square inch. Weather deck scuttle entry and exit under suppression fire. Engagement duration, 11 minutes and 44 seconds. Ship status operational. The post-engagement debrief identified the Firemain crossover repair as the single most consequential action of the engagement. Not because it was the most technically complex, but because its timing was the tightest. The breach occurred at 1:14:22 a.m. The ship regained adequate firefighting pressure at 1:21:14 a.m. In those 6 minutes and 52 seconds, the ship had no reliable firefighting capability on the port side. During those same 6 minutes and 52 seconds, the swarm's port quarter approach was most aggressive. If any of the port quarter patrol craft had scored a hit that ignited a shipboard fire during that window, a hit in a fuel locker, in the forward engine room uptakes, in the aviation fuel stowage adjacent to the flight deck, the outcome of the engagement would have been measured differently. No such hit occurred. The gun suppression fire on the port quarter, ordered specifically to create the repair window, likely contributed to the absence of that hit. The repair created the firefighting capability. The gunfire created the repair window. Neither worked without the other. The commanding officer, who made both decisions within 90 seconds of each other, was asked during the debrief how he knew to connect them. He said he had been listening to his chief engineer long enough to understand what a Firemain pressure drop to half capacity means in an active engagement, and that the gun was the only asset he had that could change what was happening on the weather deck. The board in DC Central had 3 red markers. 2 could not be fixed at sea. 1 could. The repair party leader, who had spent 3 minutes and 41 seconds in a flooded void space under suppression fire to fix the one that could be fixed, was asked by the debrief officer if he had been afraid in the void space. He thought about it for a moment. He said the sounds coming through the overhead were very loud, and that the water in the void space was warm, and that the plug installation had gone cleanly on both ends. He said he had been focused. The debrief officer wrote this down. The 5-inch Mark 45 barrel temperature reading, logged at the end of the engagement by the gun captain in the gun deck maintenance record, was annotated below the temperature reading with a single word: held.